Okay, so let's first factor the bottom. Okay, so the bottom, this is a hidden quadratic, x squared by trial and error factoring. If you factor with x squared plus 1, x squared plus 2, that'll expand to that. So the partial fraction setup here, okay, the partial fraction setup here is to let a, right, so ax plus b, sorry, a degree 1, a general form of degree 1 polynomial at the top with x squared plus 1, because x squared plus 1 is not factorable. Okay, same with the x squared plus 2, cx plus d over x squared plus 2. Okay, so let's combine these two. X squared plus 1 times by x squared plus 2. Okay, ax plus b. So I'm going to multiply this on the side here and just put the result on the top there. So ax plus b times by x squared plus 2. You're going to get ax cubed plus bx squared plus 2ax plus 2b. So let me put that there. Okay. Next, cx plus d needs to be multiplied by x squared plus 1. So you get cx cubed plus dx squared plus cx plus d. So let me put that there. Alright, so we're going to collect all the x cubes together. The same thing at the bottom. So there is one here and one there. Okay. So x cubed, you're going to get a plus c. X squared, you're going to get b plus d. X, you're going to get 2a plus c. And then constant 2b plus d. Okay. So now we got to compare this. Okay, we're going to compare that with the original given question. So there's no x cubed term, so you have again a plus c is equal to 0. B plus d, that must equal to 3, right? The coefficient in front of the x squared. 2a plus c must equal to 1. That's the number in front of the x. And 2b plus d must equal to 4. Okay. So this is the simplest equation, the first one, right? Where a, I can say a is the same thing as minus c. Okay, so wherever I see a, I'm going to replace with minus c. Okay, so this one right here, this is minus 2c plus c is equal to 1. So minus c is equal to 1, so we get c equals negative 1. We found one already. Okay, so that automatically makes a equal to 1. Okay, so the other two equations here, we just have b and d. So let me call this equation 2. This would have been 3. This would have called the equation 4. Let's do equation 4 subtract by equation 3. So I'm doing an elimination. 2b plus d equals 4. B plus d is equal to 3. You subtract it, you get b is equal to 1. Okay, b is equal to 1. If b is equal to 1, d would have to be 2. Okay. Okay, so let's write this as a partial fraction. We had x squared plus 1 with ax plus b. So a was 1, so x plus 1. Okay, and then we have x squared plus 2, right? That's what we had. Make sure you keep the order exactly the same. Then you have cx plus d. So c is negative 1, so minus x plus 2. Okay. Okay, let's separate this fraction. So we get x over x squared plus 1 dx x squared plus 1. Right, and then you're going to get a minus x over x squared plus 2, right, with that minus x, plus 2 times 1 over x squared plus 2 dx. Okay. Right, so this is integration by substitution. You let u equal to x squared plus 1. du is 2x dx. So that's equivalent to x dx you can replace with half of the u with u at the bottom, that's just going to be an arc tangent of x. Okay, and this one here very similarly, right, it's actually, because it's slightly different from this, is plus 2 here. Let's say v equal to x squared plus 2. Okay, then you get dv is equal to 2x dx. So x dx can be replaced with half of the v, so we get a half of the v, and the bottom we get just v. Okay, and this one here, okay, let's actually, this looks very similar to this first one, right? Sorry, the second one, which is arctan. Okay, but it's, because it's plus, so it's slightly different. Here's how we can make it look the same. You divide the top and bottom by 2. So if you divide the top by 2, that will disappear. The bottom, it'll become like this: x squared plus 2 plus 1. Okay, so that plus 1 is what I want. Okay, so let me just take that on the side here. Let me take down the side. I'm gonna use purple. So I'm gonna have that same thing as x over root 2 squared plus 1. Okay, so look, this is 1 over something squared plus 1, a variable squared plus 1. So this you would imagine to be arctan of x over root 2. But if you actually differentiate that, you get, okay, you get a 1 over root. So this will be, it'll be exactly this times by 1 over root 2, right? So what you want to do is just multiply the front to compensate for that by root 2. Okay, that's the antiderivative of that. Okay, so we're almost done now. This is going to be ln of absolute value of u, where u was equal to x squared plus 1. So I can remove the absolute value. Half ln of absolute value of v, where v was equal to x squared plus 2. And then plus root 2 arctan, okay, arctan x over root 2 plus constant, of course. Okay.